A very popular strategy for solving problems with students who want to advance their thinking mathematically is known as doubling and halving, which can be used anytime you have at least one of your factors that is an even number, which can be divided in half, still remaining a whole number. For this particular problem, the number 16 could be divided in half. Half of 16 is 8, while the other factor, 12, would be doubled. 12 doubled is 24. 8 times 24 would yield the same product as the original problem, 16 times 12. Continuing the doubling and halving process, because I am not yet to a problem that is easy to solve with mental math, I would again half the first factor. Half of 8 is 4. Double the second factor. 24 doubles to 48. And I could continue to half and double until I find a simpler problem, because I still have at least one even number. The number that I intend to divide in half is still even as well. Half of 4 is 2. 48 doubled would be 96. For those students having trouble at this point with doubling a number of this size, they could decompose the number. 48 is 40 and 8, and double in terms this way. 40 doubled would be 80, 8 doubled would be 16, and then adding 80 plus 16 would help them to get the 96. I'm getting closer to having a very simple problem to solve. The goal is to make it simpler. However, I can continue to double in half. Half of 2 is 1. And in doubling 96, I could use decomposition to help me double a number of this size. 90 doubled would equal 180. 6 doubled would equal 12. 180 plus 12 equals 192. I'm left with this problem, 1 times 192, which with multiplication means that I have one group of 192, which would equal 192. So we have now solved for n equals 192. We would need to write our answer in a complete sentence. Miss Frizzle bought 192 cans of soda. As students start exploring with this particular strategy known as doubling and halving, we always try to teach them conceptually why this works. And just to give you a quick example of why the doubling and halving process works, if you consider an array, which is a 16 by 12, what we did was took the factor of 16 and divided it in half to receive 8. When we did that, this dimension changed to an 8. This whole section moved here, doubling the 12. So that changed our problem into an 8 by 24 array, when you consider that that was moved, which matches the 8 by 24 problem, or the 8 times 24. And then we would continue in that fashion. The 4 times 48 would be having the 8 into 4 and moving these two sections down, which would explain the doubling of that dimension of the array. And this is how doubling and halving works.